Hello, this is Eric White. In a previous screencast, I talked about some of the utility methods and utility classes that I commonly use when I do programming using OpenXML. These are some of the functional programming methods that I commonly need when writing OpenXML examples and OpenXML solutions. All of those methods and classes were in the PtUtil.cs, and all of those methods and classes were not OpenXML specific. In this screencast, I'm going to introduce another set of classes and utilities that are OpenXML specific and can also aid you in doing OpenXML programming. The first area of functionality in this module that I want to talk about is that of pre-initialized XName objects. In PtOpenXmlUtil.cs, there are classes that effectively represent each of the namespaces that you commonly work with in word processing documents. One key point about this is that I've put together the initialized XName objects for word processing documents, but have not yet put them together for spreadsheets and presentations. That's an upcoming project. Here we have the class W, and the class W represents the word processing ML namespace. And in this static class, you can see that there are initialized XName objects for all of the element and attribute names that you commonly use in an OpenXML document. There are a number of benefits that you get because of these pre-initialized XName objects. The first benefit you get from those pre-initialized XName objects is that IntelliSense works in a nice way. Here I've written a little OpenXML SDK program to open up a document named test.docx, and I've gotten the XDocument for the main document part. And now if I want to find the body element of that main document part, I can write code that looks like this. I dot into the descendants axis, and I can then type W, which is the name of that static class, and I can now type BODY, and there is the body element name. And if I say dot first or default, that will return that body element. The second important benefit is it significantly reduces the chances that you will misspell an element name. Misspelling an element name can mean code that inexplicably doesn't work when you're querying a document, and it can mean that you are generating an invalid document if you are generating a document. So by using these pre-initialized XNames, you stand a lot smaller chance of using invalid names. One key point about this is that this issue doesn't apply to using the strongly typed object model of the OpenXML SDK v2, but there's a problem with using the strongly typed object model, which is that you can't write pure functional transforms using the strongly typed object model, or at least it is significantly harder to write such transforms. So I actually prefer using LinkedXML to write pure functional transforms. And the last and not least of benefits that you get when you use these pre-initialized XName objects is that you get a pretty good sized performance boost. LinkedXML is put together in such a way that if you have a particular XName object for a particular namespace and a specific local name, there is one and only one object in the system for that particular qualified name. If later on elsewhere you also initialize an XName object to a particular namespace and local name, it will be the same object. What this means is that if you were to look at the code inside of this descendants axis, what you would see is that this code doesn't have to do big string comparisons. All it has to do is do an object comparison. It's effectively the equivalent of comparing two pointers to see if the two pointers have the exact same value. So for instance, if you were to look at the code that the compiler writes for this little chunk of code, first of all, we initialize an X element with the name w.body, and then here we test whether that name of that element is equal to w.body. This particular comparison is extremely fast. It doesn't require any extensive string comparisons. It simply requires an object comparison. The next area of interesting functionality in PtOpenXmlUtil.cs is get XDocument and put XDocument. In these videos introducing these utility methods, you've already seen me use this extension method. Get XDocument is written as an extension method on an OpenXML part. So what I can do is I can use my word processing document, dot into the main document part, and then dot into get XDocument, and that returns an XDocument for that main document part. So let's look at that code for get XDocument. Here is the extension method. The first thing the extension method does is it looks for an XDocument annotation on the OpenXML part. If it finds one, it just returns it. If it doesn't find one, then it gets the stream, it deserializes the stream, it creates a new XDocument, and it then adds that XDocument as an annotation on the OpenXML part, and then finally it returns that XDocument. And what this means is that we can call getXDocument with impunity anytime that we want to, and we won't cause deserialization over and over and over again on that OpenXML part. That would be something that would cause it to have poor performance. I've actually seen example code that developers have sent to me that effectively caused deserialization of the OpenXML part for the main document part 1,000 times, and they were wondering why their program performed poorly, and the reason was they were deserializing and reserializing that OpenXML part many times. By placing the XDocument as an annotation on the OpenXML part, we eliminate extraneous deserializations. You can change that XDocument, and after you have changed that XDocument, you can call this method PutXDocument. And then when you call this method PutXDocument, the first thing that it does is it calls part.getXDocument, which returns that exact same XDocument that is stored as an annotation on the OpenXML part, and then it serializes that XDocument out to the OpenXML part. So what this means is that you can call getXDocument, alter that XDocument, and then call PutXDocument, and it will serialize the changed XDocument back into the part. So here's a little example that, first of all, opens up the document. It passes true as the second argument to this open method, and the reason it has to pass true to that method is so that it opens up the word processing document for read-write. It then gets the XDocument for the main document part. It then gets the body element, and then it adds a new paragraph as the first paragraph in that document, and finally it calls PutXDocument, writing that changed XDocument back into the main document part. So when we run it, it runs very quickly. And if I open that newly altered word processing ML document, I see that it does in fact have a hello world inserted at the beginning of that document. Another variation on the getXDocument method returns an XML namespace manager. If you need to query an XDocument using an XPath expression, you need an XML namespace manager. It's not particularly hard to get an XML namespace manager, but you actually have to do a little bit of fiddly code to get it. Here is the overload of getXDocument that gets a namespace manager. And what it has to do is it actually has another annotation of the XML namespace manager. If the namespace manager is not there, then what it has to do is it has to create a reader such that it can load a name table from the reader, and then it can get a namespace manager from the name table. What it means is that you can do things like the following. First thing is, in order to use XPath expressions and in order to use the namespace manager, you have to declare 2 additional namespaces in your using statements. You need system.xml and you need system.xml.xpath. To use that particular overload, you have to write code that looks something like this. You have to declare an XML namespace manager. You then have to call getXDocument, and you have to pass an out parameter passing the newly declared XML namespace manager. You then need to add the namespace prefix to that XML namespace manager. In this particular case, we want to use the W prefix, and then you have to use the namespace name when you add that namespace, and this namespace name is part of the W namespace, which is part of the W static class that is declared in PtOpenXmlUtil.cs. And after you have done all of that, then you can call XPath select element, passing this XPath expression that uses the W prefix. And the reason it can use the W prefix is because you have passed an XML namespace manager that has that W prefix initialized. And therefore you can select the body element using an XPath expression. And if we run it, it works as expected. The next interesting method is this method to get all parts. As you might know, or as you should know, parts in an OpenXML package don't form a hierarchy, they form a directed graph, which means that you can have a lot of parts and multiple parts can each have a relationship to one part. In order to get all of the parts for an OpenXML document, you have to actually keep a list, and you have to visit every element in the tree, and you have to stop visiting elements in the tree when you reach an element that you've already visited, and so on. If you've ever worked with something like a directed graph, then you know that you have to do some technique like this to get all of the parts. Here are the 3 getAllParts methods. There's one for a word processing document, there's one for a spreadsheet document, and there's one for a presentation document. And when you call this method, you can see inside of this method it creates a new hash set, and it iterates through all the parts in the hash set, adding a part to the hash set. When it calls this add part method to add the part to the hash set, the first thing that it does is it looks to see if the part is already in the hash set, and if the part is already in the hash set, it simply returns, and otherwise it adds that part, and then it recursively calls add parts for all of the parts that that particular part has a relationship to. Its use is really quite simple. Here is a little example program that calls getAllParts and prints out the URI for every part in the package. And if we run it, we can see the list of the URIs for all the parts in that particular word processing ML package. A method that is related to getAllParts but is only applicable to word processing ML packages is that of content parts. And what this does is this returns a list of all the parts that contain textual content in a word processing ML package. By textual content, I mean the content that actually can appear in some form or another in the printed document. So for instance, this would be the list of parts that might contain comments. This would be the list of parts that might contain tracked revisions, and so on. Here is that particular extension method. And what this extension method does is it first calls yield return for the main document part, and then for each of the header parts it calls yield return for that part. It also yield returns all of the footers. It then returns the footnotes part and the endnotes part if there are such parts. There are various times when processing Open XML documents that you want to get this list of parts. As an example, the markup simplifier class simplifies the markup for all of the content parts. And last but not least is the logical children content extension method. If you want to accurately retrieve the text of an Open XML word processing ML document, you have to take into consideration a number of different issues about the markup. You have to, for instance, take into consideration exactly where text boxes are. You have to take into consideration the alternate content markup that may be in existence in an Open XML word processing ML document. The logical children content extension method helps you in completely accurately returning the text of an Open XML word processing ML document. For more detail about the logical children content extension method, you can go through this article, Mastering Text in Open XML word processing ML documents. If your job entails working with Open XML documents and you need to accurately retrieve text or you need to accurately interact with word processing ML documents, I recommend that you go through this article in detail and make sure you understand everything that this article introduces. The logical children content axis method is introduced in this article, and it shows you how you can completely accurately retrieve the text of an Open XML word processing ML document. That's the end of this video on the utility methods and classes that you can find in the PtOpenXmlUtil.cs module.